Okay, we have gone through the basics of the VHDL, जितना हमें चाहिए था. Now we'll actually start designing digital circuits. Now, before we actually start writing codes for these circuits, there is a basic classification of digital circuits, and we classify them as combinational circuits and sequential circuits. Right? And you may sometimes have combinational circuits in a sequential environment. We'll take that separately. But if you talk about a basic classification, this is the basic one. And we define combinational circuit, yeah, combinational logic as a circuit whose output depends upon the input at that instant of time. So you give some current input and instantaneously you will have an output. As an example, आपके gates AND gate. For example, if you have a two input AND gate, you give the inputs and depending upon the inputs at that instant, you will get an output. Similarly, your half adders, full adders, encoders, they fall in this category, the combinational circuit. Then, so there is no concept of memory or storage in the feedback path. Since your current output only depends upon the current input, you don't need to store your previous outputs. Then we have another class, the sequential circuit, wherein apart from your current input, your output also depends upon your previous outputs. Right? So you need to store your previous outputs, and that basically represents the present state of the circuit. So it's a combination of this present state and the current inputs which will give you your current output, and present state in turn depends upon the previous outputs. This is the basic classification. I'm sure आपने digital electronics में ये पढ़ा होगा. तो यहाँ पे there is a concept of memory or storage element in the feedback path, right? So if you remember, inherently VHDL is concurrent. We did the properties of in our earlier lectures, in our earlier sessions, okay, that inherently it is concurrent. Fine. So आपका जो VHDL का inherent behavior है, it kind of satisfies this. ठीक है. Now sequential circuit में you have to mean you have to synthesize your hardware in a sequential way. So यहाँ पे we have to alter the concurrent behavior of VHDL. Okay, so accordingly, we have two types of VHDL codes. One specifically for combinational circuits, and we call it the concurrent code. जहाँ पे we don't have to alter the inherent behavior of VHDL. It is concurrent inherently. So we will use that behavior क्योंकि हमारा circuit भी concurrent ही है. There is no concept of state. And then for sequential circuit, we have to modify this. We have to alter this concurrent nature of the VHDL. So उसके लिए we have the sequential code. Fine. And we'll start by discussing concurrent code. In other words, we'll start by discussing how to design and how to code what you call combinational circuits in the VHDL. Right? So we'll be starting with the concurrent code. And in this, we basically have three methods. We have main methods, but we will do only a couple of methods क्योंकि उतना depth हमें चाहिए नहीं. One is through the use of operators. जो operators आपके VHDL में support है, you can use those operators to code your combinational circuits. Then there's another strong method wherein we can use the when else statement. This is a very powerful statement as far as concurrent code is concerned. When else या इसका एक modified version है with select when. Fine. Then there is third approach which sometimes we may use this. It is the generate approach. Similarly, block is there. Many others are there, but we'll mainly discuss this, and third one will briefly touch कहाँ पे use होगा. So first method is using operators, and this is pretty straightforward. using operators. You see, whenever you design any combinational circuit, आपका full adder हो, half adder हो, encoders, decoders, you generally have a logical expression for it in terms of Boolean functions. So using operators, you simply code that logical function. Okay? So as an example, let's suppose we have to design a multiplexer of this kind. It is a multiplexer. It has four inputs. Let's call them A, B, C, and D. It has an output Y, and then you need selection lines. आपके चार inputs है तो चार inputs के लिए you would require two selection lines, say S1 and S0, right? Now you know the behavior of this circuit is such that at a given instant of time only one of the inputs will move to the output side, और इन चार में से कौन सा इनपुट आउटपुट पे जाएगा that will depend upon the selection variable. For example, if it is 0 0, S1 is 0, S0 is 0, A will go to Y. If it is 0 1, B will go to Y. 1 0 पे C जाएगा and 1 1 पे D जाएगा. Okay? So this behavior we can actually express it in terms of a Boolean function, right? अब यहाँ पे मैं ज़्यादा डिटेल में नहीं दिखा सकता, but you can just construct a simple table wherein you have two selection variables S1 and S0, and we'll have output, right? So 0 0 0 1 1 0 1 1. For 0 0 you will have A at the output. इस पे आपको B, C and D, या it depends upon you कौन सी combination आपको रखनी है. You can choose कि 0 0 पे C जाए, right? So it depends upon you. And then from this we can actually get a logical equation, a Boolean equation for our output. So it will be Y is equivalent to A S1 naught for this particular combination plus B S1 naught S naught, because S1 is 0, S0 is 1, so naught के लिए we use this bar, 0 के लिए we use this bar, and 1 के लिए the variable appears as it is. Then plus here means or, huh? You have to kind of refresh your digital concepts here. Then C, क्योंकि S1 1 है, so S1 will appear like it is, and S0 0 है तो S0 in complemented form. Then finally D S1 S0. So you can see this is a Boolean equation. So what we do in operators, when we have to write a concurrent code using operators, we simply code this behavior using the operators that are supported in the VHDL. So I will just quickly write the code for this. हमारा जो initial part है, we will have the library declarations. So I'll be using library IEEE. Then within this I will be using some packages. जो मैंने आपसे कहा था कि at least 3 packages you should be initializing std underscore logic underscore 1164.all ताकि आप सारे logical components use कर सके. Then use IEEE dot std underscore logic underscore earth dot all ताकि आप सारे arithmetic operators use कर सके. Then unsigned in case you have to perform arithmetic operation on your std logic. Fine. So as a habit, as a convention, we'll declare these two. Then the second part is the entity part. यहाँ पे we have to be a bit careful. So entity, let's call it mux is. So we'll define some ports A, B, C, D. We will define them as mode in of the type std underscore logic. फिर आपका selection variable S, it is in std logic underscore vector 1 down to 0. दो bit का है तो 1 down to 0, S1 and S0. Okay, then we have the output Y out of the type std logic, and I will end my entity. I'll start with the architecture. Let's say behavior of mux is, then we don't need any intermediate signals, so directly we will write begin. अब ये जो boolean equation है, boolean expression है, we have to express it appropriately using our operators. So it will be y assignment operator. You can use brackets a and okay, this not s1 and not s0. So this is this part, a and not s1 and not s0. Then we have plus is or. So continue करेंगे. Second के लिए we have b and not s1. I'm using these brackets. This means first bit of s. This means 0th bit of s because we have defined s as a 2-bit vector. Not s1 and so s0 इसमें not नहीं है तो s0 हो गया second term. Then or c and s1 and not s0 और फिर जो लास्ट का कंडीशन है d and s1 and s0 like this, and we will just conclude by semicolon. Then we will end our architecture. Okay, so this is a pretty straightforward approach. You just get a boolean expression. हर किसी functionality का, logical functionality का, you will have a boolean expression. Then you appropriately code that boolean function using the operators, just like we did here. Okay, so this is the operator usage, right? I'll stop here. In the next video we will see how to code using when else, yeah, with selective when.